Hi guys, welcome to this video on finding the equation of a parabola where the vertex is not 0, 0, or not the origin. Alright, I'm going to just give you the formula straight up, the equation of the parabola. So this is the concave up parabola where now the vertex is not 0, 0, but the vertex is h, k. So this is the vertex of this particular parabola. If we wanted the concave down parabola, it would be very similar. It would be x take away h all squared, and you can guess it, negative 4a y minus k. If we wanted to look at the concave right parabola, a few things change here. So the y value will be the y squared, so it will be the y take away k squared is equal to 4a x take away h. Still, the vertex is h, k. So this is the concave right, and the concave left is y take away k all squared is equal to negative 4a x take away h. So these are the different ones. So this one here is concave down. This one is concave right, and this one here is concave left. So if it's in this form, that's great. If it's not, we can use our work with algebra to find out the equation in this particular form. All right, so why is that particular equation, the equation of the parabola? We'll go through in detail what is happening. Okay, so we remember that any particular, let's say this point P here is x, y, so we know that this distance is equal to that distance here. Okay, so that distance is equal to that distance, don't forget the right angle, and that was the equation of that was the definition of a parabola where it's equidistant from a fixed point, which is the focus, to a point P, which is also the same distance from P down to the directrix. Alright, so point P slides anywhere. There's our equidistant relationship. Alright, so now this distance here is the focal length. We call that A, which is the same distance going down here. So the focus and the vertex have the same x value. The difference with the y value is this extra a value from the k. So that's why we have k plus the focal length. This distance here we said was a. So the directrix has equation y equals k take away the a value. So that's why we've got k take away a. And this point M, which is obviously perpendicular, has the same x value as our point P, and the y value sits on the directrix. Okay, so now let's try and see what's happening with our equation. So again, start the question off. Let P be a point in the plane such that the distance of PS is equal to the distance of PM. We like to work without the square root symbol, so let's just now square it. Using our distance formula squared, we have x take away h all squared. So we've got x take away h all squared, and then the y value, which is y take away, and then in brackets, k plus a all squared. And then this distance here, you can just look at the y values. But if you're going to use the distance formula squared, this is what we end up having. A little bit more complex than our vertex form because of the algebra, but the process is still the same. I'm not going to go too much into detail, but you expand all your terms, expand everything, cancel on either side what is common, so subtract the y squareds, subtract the a squareds, the k squareds, and then negative 2ky. It works quite nicely here. We don't bother expanding this only because it ends up factorizing later on, so you might as well keep it in that form. And then on the right hand side you can also factorize. So x take away h all squared is equal to 4a y take away k. Similarities between this one and the vertex form. Well, you got the 4a, you got the x squared, and then you have the y. With our vertex form, h is equal to 0 and k is equal to 0 when the vertex is at the origin. So it's really the same thing, but normally we just have x squared equals 4ay. Nice and simple, nice and straightforward. Here we've got the vertex changing position on the number plane. All right, so that's the proof of why the equation is the way it is. All right, let's have a look at a few questions here. We've got from our recent HSC 2016. Question 13b, it says, consider the parabola x squared take away 4x is equal to 12y plus 8. You've got two components. You've got part I, complete the square or otherwise. They're indicating to us that completing the square is going to be the best option, so maybe use that particular method. Find the focal length, which is the value of a. And then, obviously, read the next part. It says, find the coordinates of the focus. So we need to use the focal length to find out where the focus is going to sit. All right, so step number one, here's our equation given to us from the question. Remember, we want an x take away something all squared. So we're going to complete the square because we got x squared take away 4x, but we don't have that number. We don't have that, halve the 4, square it, which is a plus 4. So we need to add the 4 to both sides. Once we've added the 4 to both sides, there's our expression, x take away 2 all squared. There's the value of the x component for the coordinates of the vertex. And then on the right-hand side, it factorizes nicely, and here is the y value for the part of the vertex. Doesn't say anything about a vertex in the question, but we will need it for the focus. Okay, so that leaves us with this being 4a. So 4a is equal to 12. A is equal to 12 divided by 4. So there is our question completed. I've indicated the vertex because that's the next component. Just for my benefit, I've indicated that. Okay, so there's a positive right there. So it's concave up. So therefore, if you just visualize where 2, negative 1 is, so 1, 2, so right here, there's the vertex. There's a turning point. And now we have 3 units going up. So there's 1, there's 2, there's 3. So on our vertical axis, it goes up to a height of 2. So our focus right here is 2, 2. I do recommend that you sketch something like your vertex and maybe the focal length. So there's a distance of 3 right there. So you know where the position of the focus is going to be. If you don't know where the vertex is, geometrically, that will cause a problem because you're doing a lot of it in your head. So a nice sketch, and then obviously draw your parabola if you wanted to see what it looks like. So answering the questions, complete the square, find the focal length, and then find the coordinates of the focus. Okay. Second question is from a 2013 component, and that was a multiple choice question. So it says a parabola has a focus of 5, 0, so again, draw it. Even though it's a multiple choice question, which has multi-step parts to it, it's nice to show all your workings so you maximize your chance of answering this correctly. So 5, 0 is your focus. Directrix is the vertical line, x equals 1. So this is not going to be concave up or concave down. It's going to be concave left or right, depending on the direction. So this distance right here needs to be found. So from 1 to 5 is a distance of 4. And we know that equidistant will be the midpoint, so the midpoint right here at 3, 0. So there is going to be our vertex. Our vertex is at 3, 0, which tells us the A value, which is 2 units. So write that down, A equals 2. So 4A is what we need for our equation, which is 8. Writing down our vertex, because this is the H value, this is the K value. Now it's in the form that it's concave right, because it has a positive 4A, concave right. So then it's going to be the Y value squared. So this is where the K value comes from. This is where the H value comes from. Substitute and then simplify that. So our equation of this particular parabola with these criteria, the focus and the directrix at that particular point, is going to be y squared is equal to 8 brackets x take away 3. Okay, so just to recap on the equations, most of the time you need to complete the square, a technique that we've looked at in algebra. So this is concave up, this is concave down, this is concave to the right, and the negative with the y squared is going to be concave left. So those 4 particular ones you need to know how to use and apply. 2 different scenarios, and remember H, K is the vertex. You will see from time to time different formulas for memorizing the focus and all that sort of stuff, and even the directrix. I don't tend to do that because you're not really understanding the values of those variables. So it's really important that you sketch it and then apply your knowledge from the vertex and the focal length to find out the focus, and obviously subtract it to find the directrix. So that's why I haven't given you something to memorize, but here is some information so you can apply it to different scenarios. All right, thank you for watching that video on the general form of a parabola, which the turning point is not at the origin.